Okay, so to finish off section 2.5, we will do the introduction to compound interest. These are the word problems in section 2.5. So 43 through 48. Right. And we're dealing really with two formulas. The compound interest formula, and we'll talk about where these things come from and how they get this way when we do compound interest and continuously compound interest in section 3.2. A equals P1 plus R over M to the MT. That's the compound interest formula. A is the amount in your account at some time in the future. P is you deposit your principal amount you invest or save. R equals the interest rate, always and forever as a decimal, right? They'll give it to you as like 6%, but 6% means 0.06. M, number of compounding, I suppose I should write out number of compounding periods per year, and again we'll talk about that more when we get to section 3.2. And then T equals time, and time also has a restriction. It's always in years. Okay, so this is the formula. Note that time is in the exponent. This is an exponential formula, and the idea is you take P, that's how much you're investing, and you put it into a bank or wherever at a particular interest rate, and the amount of money you have grows over time, because that's how interest works. So that's the compound interest formula. And so we can do a problem along these lines. So suppose you want to have $10,000 in 3 years. Right? And there's a number of different investments you can make, but all of them are basically saying, to get $10,000 in 3 years, you have to give us this much money now and we'll invest it for you. And so you talk to some bank and they can say, well, a bank says they'll give you 6%, oh no, 3% compounded weekly. So how much would you have to give them at this rate to get 10,000 in 3 years, right? So they say, well, we'll give you 3% compounded weekly. How much do you have to give them now so that in 3 years that'll your money will become $10,000? So what does compounded weekly mean? That means at the end of every week they calculate how much interest you get and they add it on top of how much money you have. So if you give them $100 at the end of the week, they say 3% interest on that. Well, that's $3. And so at the end of the week, you have $103. At the end of the next week, they repeat it, and then next week they repeat it. So compound interest problem, compounded weekly. So A equals P1 plus R over M MT. You have to memorize this formula. That's one of the things that the business college wants, is that people come into the business college knowing what this formula is. A is the amount in future. P is the amount you invest. R is the interest rate. M is the number of compounding periods per year. And T is time. So what do you want? You want $10,000 in the future. They'll give you an interest rate of 3%. And remember, that has to be a decimal. And you want it in 3 years. How often do they compound interest? Well, they do it weekly, so that means 52 weeks in a year, so 52 is M. And what you want to know is, what's the principal? How much do you have to invest now so you have that $10,000 later? For many of these interest problems, this is the format, right? Is like this. There's a formula and a bunch of different variables. the problem, the statement of the problem will give you all of the variables, right? Here was A, R, M, and T, except one, and you have to find out the other one. So, what I usually do if I'm looking for P is I'll calculate this part first. What's this going to be? It's going to be 1 plus 0.03 divided by 52. That's a 3 and not a 5. All of that raised to the 3 times 52. So M is 52, T is 3 years. Okay, lots of parentheses in here. Be very careful when putting this into your calculator, because your calculator can easily get the order of operations wrong if you don't tell it specifically what the order of operations should be by putting in parentheses around your division and then parentheses around the base that gets raised to that. And so if you grind that into your calculator, you should get out a number that starts out 1.0941 and more digits depending on how much accuracy you have there. Let's see if we can move that. Okay, so A is 10,000, and so P should be 10,000, that's my A, divided by this number, 1.0941, more stuff, right? So it's A divided by this whole part, and that gives you P. And if you actually grind that out, you get 9,139.54. That's how much you'd have to give them to get $10,000 in 3 years. You'd have to give them, $91.40, and you could pick up the other, what's that, $860 in interest over the 3 years. Okay, so that's how many of these compound interest problems work. They'll give you 4 out of the 5 variables, and you have to find the 5th. The other formula is the continuously compounded formula. Continuously compounded interest. And again, we'll talk about this a little more when we get to section 3.2. And this is A equals P e to the RT. And A is, again, the amount in your account in the future, because you've invested money and you're waiting for it to grow. P is the principal. That's also the amount you invest, how much you put away into your bank. R is the interest rate, and again, that's a decimal. And T is time, and time is always in years. And this is one of the reasons why we want to introduce E. Right? In this formula, E is just a number, 2.7 Andrew Jackson. But when you're doing the continuously compounded interest formula, the number E just appears sort of naturally there. And continuously compounded, well, the previous example, we were compounding at the end of every week. You could imagine if you could compound at the end of every day, you could compound at the end of every hour, every second, every millisecond, every microsecond. And E is, if you take that to its theoretical extreme, if you compound it every single instant, how much would you get? And that's what this formula is. So, okay. Problems here are the same as sort of with the compound interest problems, except this formula's got 4 variables. It's another formula that you have to memorize. And they'll give you 3 of them and tell you what the 4th one is. So suppose you have a problem where you invest $10,000 at 2.25% compounded continuously. How much will you have in 60 months? Or how much is in the account in 60 months? Okay. And note, if you have a problem that says compounded continuously, then you have to use the continuously compounded interest formula. If you have a problem where they say it's compounded weekly, compounded monthly, compounded annually, something like that, then you have to use the compound interest formula. So let's go back down to our problem. Compounded continuously, so we're looking for the continuously compounded interest formula. A equals P e to the RT. Four variables here, A, P, R, and T. E, of course, in this formula is just a number, 2.7. So we're actually investing 10,000. That's actually the principal, because that's how much we're putting in. 2.25%, converted to a decimal, 0.0225. 60 months. Well, 60 months, 12 months a year, so that's actually 5 years. Time always has to be in years. So they give us 3 of the 4 variables, and they want to know what the fourth one is. So A equals, this one's pretty easy, just plug everything in, 10,000 e to the 0.0225 times 5. And if you plug everything in, you should get 11,190.72. So $10,000 for 5 years at 2.25% interest compounded continuously is $11,190.72, about what, $1,190 in interest. So that's just sort of an introduction here. Note that interest is an exponential function, right? I mean, here it's really explicitly e to the RT, and also in the compound interest formula, it's an exponential function. And it's exponential in time, right? And so if you want to know how long something would be, how long it'll take for something to happen, you have to solve that for t. Okay,